On the morning of the 30th of June 1908, at about 7:15, something came out of the sky over central Siberia and exploded before it reached the ground. It flattened forest across 2,150 square kilometers. It left no crater, and it happened in one of the emptiest places on Earth, which is the only reason this is not the worst disaster in recorded history. Evenki people and Russian settlers in the hills northwest of Lake Baikal saw a bluish light, nearly as bright as the sun, moving across the sky and leaving a thin trail behind it. Closer to the horizon, there was a flash, then a billowing cloud, then a pillar of fire that threw red light across the landscape. The pillar split in two, faded, and turned black. About 10 minutes later came a sound like artillery fire. Witnesses closer in reported the source of the sound moving from east to north as they listened. With the sound came a shockwave that knocked people off their feet and broke windows hundreds of kilometers away. We know what that felt like because a mineralogist recorded the accounts 22 years later, and they are extraordinary documents. A man named Semenov was sitting by his house at the Vanavara trading post about 65 kilometers south of the explosion at breakfast time, facing north. He said the sky split in two, and fire appeared high and wide over the forest. The split grew larger, and the entire northern side was covered with fire. At that moment, he said, he became so hot that he could not bear it, as if his shirt was on fire. He wanted to tear it off and throw it down. Then the sky shut closed, a strong thump sounded, and he was thrown a few meters. He lost his senses for a moment. His wife ran out and led him back to the house. Then, he said, came the noise, as if rocks were falling, or cannons firing. The earth shook. He pressed his head to the ground, fearing rocks would smash it. Hot wind raced between the houses, leaving traces in the ground like pathways and damaging crops. Windows were shattered. In the barn, part of an iron lock had snapped. Closer in, a man named Chuchan was asleep in a hut by the river with his brother Chuchan. They both woke at the same moment. Something shoved them. They heard whistling and felt a strong wind. Chuchan asked whether the other could hear all those birds flying overhead. Then the shove came again, hard enough to throw Chuchan into the fire. Outside, trees were falling. The thunder struck. The first thunder, he called it. The earth began to move and rock, and the wind knocked their hut over. Trapped under the sticks with his head clear, he saw what he called a wonder, trees falling, branches on fire, and it became so bright as if there was a second sun. His eyes hurt. He closed them. He said, the morning was sunny. There were no clouds. Our sun was shining brightly as usual. And suddenly, there came a second one. They counted the thunders. There were at least 5, the fourth like normal thunder, the fifth small and far away, where, as he put it, the sun goes to sleep. Regional newspapers reported it within days. In one village, peasants 200 kilometers away saw a strangely bright bluish-white body, impossible to look at, moving downward for 10 minutes. They described it as a pipe, a cylinder. As it neared the forest, it seemed to smudge, then turned into a giant billow of black smoke, and a loud knocking was heard, as if large stones were falling. All the buildings shook. The cloud began emitting flames of uncertain shapes. All the villagers, according to the report, were stricken with panic and took to the streets, and the women cried, thinking it was the end of the world. From another village, a horrific thump, an earthquake that shook the buildings as if hit by a heavy log, and then 5 or 6 minutes of what sounded exactly like artillery, 50 to 60 salvos in short equal intervals, getting weaker. And all of it under a clear sky, with no wind and no clouds, except an ashen cloud near the northern horizon, which kept getting smaller and more transparent until it disappeared by the middle of the afternoon. The explosion registered at seismic stations across Eurasia. In some places, the shock wave was equivalent to an earthquake of magnitude 5. Air waves from the blast were detected in Germany, Denmark, Croatia, and the United Kingdom, and as far away as Batavia in the Dutch East Indies and Washington, D.C. Over the following nights, the sky over Asia and Europe glowed. Not faintly. There are contemporaneous reports of photographs being taken successfully at midnight without flash in Sweden and Scotland. It has been suggested that the glow came from light passing through high-altitude ice particles formed at extremely low temperatures as a result of the explosion, an effect reproduced decades later on a much smaller scale by space shuttle launches. In California, a Smithsonian program at the Mount Wilson Observatory recorded a months-long decrease in atmospheric transparency, consistent with a great deal of suspended dust. Those measurements have since been used to calculate that roughly 1 million tons of dust were put into the stratosphere. So, an explosion registered on 3 continents, a sky that glowed for days, and newspaper reports within a week. And then, for 13 years, nobody went to look. Partly that was distance. The Podkamennaya-Tunguska river basin was, and largely still is, extraordinarily remote, days of travel from anywhere, through swamp in summer and deep cold in winter. and partly it was history. The 1910s in Russia were a war, a revolution, and a civil war. Expeditions to remote Siberia to investigate a bang were not a national priority. In 1921, a mineralogist named Leonid Kulik led a survey to the region for the Soviet Academy of Sciences. He never reached the central blast area, but he collected the local accounts and became convinced a giant meteorite had struck. To get funding for a proper expedition, he made an argument the government could act on. There might be salvageable meteoric iron out there. It worked. In 1927, he led a scientific expedition to the blast site, hiring local Evenki hunters to guide his team to the center. They were looking for a crater. There was no crater. Instead, at ground zero, they found a zone roughly 8 kilometers across, where the trees were scorched and stripped of branches and still standing upright. Further out, the trees were partly scorched and knocked flat, all of them lying away from the center, in a vast radial pattern. That pattern is the signature of an explosion in the air. Directly underneath, the blast wave arrives, traveling straight down. It strips the branches but pushes the trunks along their own axis so they stay up. Further out, the same wave arrives, traveling closer to horizontal, and pushes the trees over, which means the standing trees mark the spot the object never reached. By the 1960s, the leveled zone had been mapped at 2,150 square kilometers, a shape resembling a gigantic spread-eagled butterfly with a wingspan of 70 kilometers and a body length of 55. Soviet researchers reproduced that butterfly in the mid-1960s using model forests of matchsticks on wire stakes and small charges slid down wires. The shape told them the object came in at about 30 degrees above the ground. Kulik, meanwhile, was still looking for his crater. He found several dozen small pothole bogs, 10 to 50 meters across, and thought they might be meteorite craters. He drained one 32 meters across, known as Suslov's crater, in a laborious operation. At the bottom, he found an old tree stump, which ruled it out completely. That is what real fieldwork looks like. Months of effort to prove that the thing you hope for is not there. In 1938, Kulik arranged an aerial photographic survey covering the central 250 square kilometers of leveled forest, 1,500 negatives. Those original negatives were burned in 1975 by order of the chairman of the Soviet Committee on Meteorites as part of an initiative to dispose of increasingly flammable nitrate film. Positive prints were preserved for study. So what was it? The leading explanation is a meteor airburst, a stony asteroid, something like 50 to 60 meters across, exploding 5 to 10 kilometers above the ground. It approached from the east-southeast, probably at around 27 kilometers per second. Objects hit the atmosphere every day at a minimum of 11 kilometers per second. The air in front of them cannot get out of the way, so it compresses, and compressing air heats it. Most of them burn up or explode long before reaching the ground. At Tunguska scale, that ordinary process becomes a bomb. Estimates of the energy released have ranged widely, from 3 to 50 megatons, depending on the method. Early estimates based on nuclear weapon scaling laws gave 10 to 30 megatons. More recent calculations, which include the object's downward momentum, find more of the energy was directed downward than in a nuclear blast, and give 3 to 5 megatons. A 2019 paper suggests around 20 to 30. The honest summary is a range, not a number, and that range spans a factor of 10. For scale, 15 megatons is about 1,000 times the Trinity test, roughly equal to the Castle Bravo test of 1954, and about a third of Tsarbomba. And this happened over a forest, at breakfast time, in the middle of a continent. Eyewitness accounts suggest up to 3 people may have died. It is the largest impact event in recorded history. It killed almost nobody. Those two facts are held together by geography and nothing else, because an explosion of that magnitude would be capable of destroying a large metropolitan area. There is a detail here that ought to be better known. The Tunguska object arrived during the peak activity of the Beta Taurids, an annual meteor shower, and the Earth turns. A calculated risk corridor shows that if the impactor had arrived a few minutes earlier, it would have exploded over the United States or Canada. A few minutes. That is the entire margin between an obscure Siberian curiosity and the defining catastrophe of the 20th century. For decades, the leading candidate was not an asteroid, but a comet. In 1930, the British meteorologist F.J.W. Whipple suggested the Tunguska body was a small comet. A comet is dust and volatile ices, and could have been entirely vaporized by the atmosphere, leaving no obvious trace, which fits the absence of a crater and of any large fragment. It also fits the glowing skies. Dust and ice dispersed from a comet's tail across the upper atmosphere would explain nights bright enough to photograph by. The comet hypothesis was generally accepted among Soviet investigators by the 1960s. In 1978, the Slovak astronomer Subor Kresak proposed a specific culprit, a fragment of Comet Inca, a periodic comet that stays within Jupiter's orbit and produces the Beta Taurid meteor shower each June. Then, in 1983, the astronomer Zdenka Sekanina published a serious criticism. A body of cometary material on such a shallow trajectory ought to have disintegrated high up, and this one apparently stayed intact into the lower atmosphere. His argument was that the evidence pointed to a dense, rocky object of asteroidal origin, and that is where the mainstream view sits today. There is physical evidence too, though it is contested. Expeditions in the 50s and 60s found microscopic silicate and magnetite spheres in the soil, later also in the resin of the trees, with high nickel relative to iron, a meteoritic signature. Peat bogs at the layer corresponding to 1908 show carbon, hydrogen, and nitrogen isotope ratios that differ from the layers above and below, and an unusually high proportion of iridium, the same metal that marks the dinosaur extinction boundary. But here, the scientific record is admirably blunt. As one summary puts it, measurements performed in other laboratories have not confirmed these results. A boulder at the site, known as John's Stone, was proposed as a meteorite remnant. Oxygen isotope analysis showed the quartzite is of hydrothermal origin, probably related to Siberian volcanism hundreds of millions of years earlier. And two of the most repeated Tunguska facts are simply wrong. The famous figure of 80 million trees felled comes from a preliminary guess that multiplied tree density by an impacted area overestimated by a factor of 4. And the trees themselves were smaller than the legend. The largest accurately recorded felled trunks are around 44 centimeters in diameter, not the meter-thick giant some accounts describe. There is also a genuinely strange recent proposal. In 2020, Russian scientists modeled asteroids passing through the atmosphere at oblique angles, and found the best match to the observations was an iron asteroid up to 200 meters across. Not one that exploded, one that skimmed the atmosphere, traveling at about 11 kilometers per second, and glanced off, returning to solar orbit. In that model, there is no crater and no fragment because the object never stopped. It touched the top of our atmosphere hard enough to flatten a forest, and carried on. That is a minority view, not the consensus. But it is a good illustration of the state of this problem, 118 years on, roughly 1,000 scholarly papers in, and the object's identity is still genuinely open. Which brings us to the question that actually matters: how often does this happen? Since the second half of the 20th century, infrasound monitoring and satellites have shown that asteroid air bursts with energies comparable to nuclear weapons occur routinely. Air bursts of about 5 kilotons happen roughly once a year. Eugene Shoemaker estimated 20 kiloton events annually, and Tunguska-sized events about once every 300 years. More recent estimates put Tunguska-scale events at about once per 1,000 years. Most are asteroids, rather than the mechanically weaker cometary material, judging by how deep they penetrate before breaking up. The largest airburst observed with modern instruments was Chelyabinsk in 2013, about 500 kilotons, which shattered windows across a Russian city and dropped meteorites on the snow. Chelyabinsk was a fraction of even the lowest estimate for Tunguska, and it injured 1,491 people, almost all from flying glass, as they stood at windows watching the light. That is the practical lesson of both events, and it is oddly domestic. When the sky does something spectacular, the danger arrives second, and it usually comes through the window you are standing at. Tunguska had one more effect that took decades to work out. Modeling suggests the shock waves generated up to 30 megatons of nitric oxide in the upper atmosphere, which attacked the ozone layer. The result was an estimated peak ozone depletion of 35 to 45% in early 1909, around 30% in 1910, 15% in 1911, and a tripling of ultraviolet intensity at the ground at mid-latitudes. A single rock, 60 meters across, damaged the planet's ultraviolet shield for 3 years. Which is really the point of this story. Tunguska is usually told as a mystery, the crater that is not there, the comet that might have been. The mystery is the least interesting part. The interesting part is that a stony object the size of a large building, arriving at a speed you cannot picture, does not need to reach the ground to flatten 2,000 square kilometers of forest and be heard in Washington. It arrived at 7:15 in the morning, above forest, in the emptiest quarter of the largest country on Earth, a few minutes off from a very different history. And the same shower comes round every June,